Hello the internet and welcome back to my channel. On the bench today we have a motherboard. It's a Biostar NS4 ST-A9. It's a socket 939 motherboard for AMD CPUs. It features the NVIDIA Enforce 4 chipset. I haven't got anything like this in my stash, even just it's so colorful, just for the colors. It's worth having one of this. This motherboard is faulty, so today we're gonna see if we can fix it. This was sent by one of my viewers, Ash, from the Retro Web community on Discord. And let me take a second to just say thank you to everybody involved within the Retro Web project. I'm always giving it for granted that it's there. I'm always expecting, when I'm Googling a motherboard, for the Retro Web to come up with drivers, manuals, jumpers, all sort of information. It's an amazing project. I wouldn't know how we could do without it. So if you're involved within the Retro Web project, thank you very much for what you've been doing. Now, let me thank today's sponsor, PCBWay, and let's see what we can do for this motherboard. My understanding is that this motherboard had a short, and Ash tried to at least figure out where the short was coming. And I think I can see it's done a little bit of work here where the phases for the CPU V-core are located. And I think the idea was just to disconnect some Mosfets to ascertain whether the short was there as well. And my understanding is that yes, the short is with some Mosfets and they just need to be replaced. I don't know, we'll take a look at that. Now, every time you see an inductor like this on a motherboard, usually means that there is some sort of switch in power supply nearby. And the way it works with V-core on more or less modern motherboards is by using what's called phases. If you look closely, where there is an inductor, you have two semiconductors like this. These are two Mosfets, and you have two per inductor, so two here, and two here. And these Mosfets, the way it works is just that they generate a little pulse, but each pair of Mosfets generates the pulse at a different time, different phase compared to each other. So eventually there is a microcontroller, which I'm assuming is this little chip here, which is driving those Mosfets and pulsing at the right time. So eventually, when these pulses are going through the inductors, you end up with a pretty accurate and pretty linear voltage after the inductors. And this is a very efficient way. Rather than using anything else, you get 12 volts from the power supply and you generate whatever you want using the controller which is on board. And that's why on modern board you can select the voltage that you want for the CPU. Now, my understanding is that the 12 volts was shorted on this board, so you might be able to see here. We'll go under the microscope in a second. Ash did a little bit of work, and I think he just forcibly removed the legs of those Mosfets from the motherboard to see whether the short was disappearing, because that would point at the Mosfets themselves. I would say let's move under the microscope so I can show you exactly what's happening on the board right now. This is one of the phases on the motherboard. You see the inductor here and the two Mosfets. This is a healthy phase as far as I understand. And if I change the lighting, you can see the Mosfets. One is a PHD78N0, and the other one it says NO2. I think it's something I managed to find online. I have some spares. But this is how it's supposed to look. Let's check the one that Ash worked on. As I said, Ash forcibly removed the Mosfets from the motherboard. To be honest, I can understand it's quite difficult to work in there. You can't see from the microscope, but this is surrounded by capacitors, surrounded by inductors. So we might need to make a decision of removing some of the components to work around it. Otherwise, we just damage everything. There is only one damage I can see. Everything else can be safely removed. I mean, this Mosfets here can be removed with a little bit of heat. This one as well, but I think I see some damage here. Let's zoom in and take a look. And yes, unfortunately, the pad of that Mosfet has come off. So it's not the end of the world, I would say. We can recreate that. There's also a little via, never remember how to say that there. So we need to make sure that this is connected to something. I guess we can fix everything. And first thing first, I would say, let's see if we still have a short anywhere. Let's check first between ground and all the three phases. You'll hear that the multimeter is beeping, but this is not a short. This is just 30 ohms. That's totally fine. And the other phase is reading the same, and the other one is also reading the same. Now let's check on the existing Mosfets. I only have short on this pin here, which is common with all the Mosfets here, but again, the pair of Mosfets is eventually connected to ground, so it's okay to read a short on at least one of the pins, well, on one of the pins. And no, I'm not reading any dead short with the remains of those components, so I don't know, it seems to be okay, though I was hoping to read a short on some of the legs which are not connected to the PCB anymore, but again, there's not much left of those legs, so maybe that's the reason why I'm not reading anything. Well, anyways, those MOSFETs need to be replaced. There's no point in power up the motherboard, and as I said, it's a bit on the complicated side, because we have lots of skyscrapers here. We got capacitors, we got inductors, and this is a motherboard, which means lots of ground plane and power planes. What that means is that most of these components here, because we are close to the CPU and where voltage is being generated, they are connected to large sheets of copper, which are extending throughout the PCB. It's basically like soldering on a heatsink. The heat will be dissipated through the copper sheets around the motherboard. So I tend not to use hot air when I'm dealing with those things, because I would at least need to preheat the board. But I don't know, usually it takes quite a lot of heat to get to a melting temperature of, I'm assuming this is a post 2000 board, so it's leaded-free solder. It means higher melting temperatures. What I like to do usually is to use a blob of solder, a big tip, maybe low melt solder, and remove everything, and happy days. That being said, I think these capacitors and these inductors are definitely in the way. I think I'd like to try and remove them, and for the occasion I think I'm going to try a new tip which I recently purchased exactly for these purposes. And it's this monstrosity here. It's from AliExpress, so it's not JBC. But the idea is that hopefully with this I can desolder a capacitor in one go, just touching both the legs at the same time and pulling the capacitor on the other side. And then there is a challenge of trying and clean the holes, of course. But we'll cross the bridge once we get to it. Let me maybe get my preheater. This board will need some preheat, otherwise it's going to be a nightmare. I'll take some notes on what goes where. And I guess it would be a good idea to make a little bit of space around those components. I think it's going to be better. While the board is cooling down, let's take a look at these capacitors. We have these 3300 microfarad, 6.3 volts. And at 100 Hz, they read 2840 microfarad, which might still be within tolerance, but it's a little bit on the low side, 45.2 milliohms of ESR. Now I have an identical one, a brand new one from Panasonic. I think that's an FR series, so one of the best you can buy. and this is reading 3.3 millifarad more or less with the same ESR. So considering how complicated it is to solder and desolder on those ground planes, I'd be tempted to replace all of this. I think there's nothing too wrong with them, they're just a little tired, they're not... I see something, not sure whether it's some leakage, but probably it's just production residue, so I'm not too concerned about that. I don't see any bulging or anything, but these are on the low side. I'd like to change them. And then we have these Nichicone. These are KZG series, and these are 1500 microfarad 16 volts. And if I test them, they actually read pretty spot on, but I think I'm used to seeing these blown on motherboards, these very series from Nichicone, so maybe if I have them I'd like to replace them anyways, just to be on the safe side. Now we got the MOSFETs out and the board is clean. Let's solder the replacement, let's fix that broken trace, replace the capacitors, well, and see if the motherboard by any chance it works. Let's see what I got from the internet. I think some of these MOSFETs are coming from eBay and some are coming from AliExpress because I couldn't find them anywhere else. Let's take a look. This is the replacement for the ones that says NO2. I haven't got any acetone with me. This is isopropyl. See if anything nasty comes out of these chips. No, they seem to be okay. Yeah, hopefully they're genuine. Let's check the other one. Now there is not much left on the old one, but BHD78NQ is what is on the other one, still on the motherboard. Let's have a look at this one. Yeah, it looks fine. It's definitely not printed. It's like laser engraved. Nothing nasty coming out. So let's install them and see what happens. I'm going to use a soldering iron. Not a fan of using hot air unless it's really necessary. Now, one thing I've noticed while I was cleaning is this little ripple here, and it doesn't come off with solder wick, so I'm assuming this is just some damage on the actual plate on the motherboard. Let's inspect a bit closer. Yeah, I think you can see that the pad has got squished a bit here in the middle. It shouldn't be a big deal, even though there's a leg which is supposed to sit in there, so hopefully that's not going to affect the alignment of the chip. All right, let's begin with the first IC. As you can see, I'm using the largest tip I have, and it's almost impossible to solder here in this corner because this is a big ground plane. It's stitched to other layers here, and it's basically like soldering on heatsink. It just doesn't solder. Despite having the higher temperature than the average, I might need to preheat this board a little bit. Come on, there you go. The metal pad of the MOSFET should be fully soldered to the pad on the motherboard, as that is also acting as a heatsink. I was concerned that just adding solder from one of the edges was not enough, so I removed the MOSFET and pre-tinned both the motherboard and the MOSFET pad. It might have not been necessary, but better safe than sorry, I guess. Now, unfortunately, you won't be able to see my postcard from the camera because this board only has PCI slots and not ISA slots. For ISA slots, I made this little 90 degrees contraptions where you plug them into an ISA slot so you can see my post-analyzer card here. But I haven't made one for PCI. Maybe I should make one with the help of PCBWay, the sponsor of this video. I designed these myself. The designing process is not straightforward if you've never done it, but you don't need to be experts when it comes to PCBs. There are plenty of projects online of any sort, including this project, which is free to download from PCBWay.com, or you can just place an order by going on the PCBWay.com store and select the item and put it in your cart. Whether you're purchasing something which is ready-made on the PCBWay store or you're downloading the Gerber file of an existing project and uploading it on PCBWay.com, well, the system is more or less automatic. A few selections and PCBWay will manufacture the PCBs with the highest standards and then send it to your place. So it's super easy. I think I might want to make a PCI version of this, so watch this space. For now, take a look at PCBWay.com. It's not just PCBs, it's also 3D prints, metal sheet fabrication and CNC machining. So plenty of options for all this project. Finally, let me thank PCBWay for sponsoring my videos on my channels, because their help makes these videos possible. So thank you very much PCBWay for helping me out. Now let's go back to this Biostar motherboard. Right, the MOSFETs are back on the board. I'll quickly check for shorts and then it's time to put the capacitors and the inductors on the board, and I'll try and replace the capacitors if I have them available. Now, one way to chase for faults is to compare one circuit to another, and I believe that these phases are identical one with each other, so I'm checking the resistance between ground and each one of the pins between the two phases. Now, this pin here is ground itself, 1.2. These probes, they actually read about 1 ohm when they're shorted, and this is also reading 1.2, which is fine. This tab here, this is the working phase, is reading 35 kilo ohms, and this is reading 35 kilo ohms, so it looks fine. This is the gate. Is that the gate? This is the gate of the working phase, 39 kilo ohms, and the one we just replaced is reading 39 kilo ohms, so that's fine. I'll move to the other IC. This is the other gate, and it's reading 99 kilo ohms more or less, and this one with the bodge wire on top is reading, well, 100 kilo ohms. I guess it qualifies to be fine. The drain reads 35 kilo ohms, and on the one we replaced is reading exactly the same. And finally got the drain of the good phase. Well, it's jumping all over the place, and then it settles on 70 kilo ohms. Let's check the one we replaced. Jumping, and then it settles on 70. So they read exactly the same, so hopefully they're fine. Alright, I'm ready to test, and I'd say before plugging anything into this motherboard, let's remove everything, power on, measure the voltage, make sure there's nothing horribly wrong happening with the VRM. And let's try and power up the board in 3, 2, 1, go. Yeah, I mean, nothing horrible happens. Obviously nothing happens, there's no CPU. Let's check the voltage on that VRM. I'm not expecting much, probably even nothing. As there's no CPU, I'm expecting the controller maybe not to even start if there's no CPU installed. Well, I'm reading 0.4 volts, more or less all 3 phases. I'm actually curious to see whether I can see those phases with my scope. Bear with me. And no, there is no switching, there's a constant more or less 500 millivolts and nothing really happens. So I can only hope that having a processor in will turn on the system, because right now it's clearly not working. Now to test this board, I'm going to use my trusty S3, which is a PCI video card. I hope the motherboard is set to work straight away with the PCI, because this board has, I think, has a AGP and PCI Express. So who knows? And then I guess I'll put a battery. You never know that this motherboard doesn't like running without a battery. And then I have some DDR RAM in here. This is 512 megabyte. I'll only install 1 stick. Hopefully that's gonna work. And finally, the CPU, which is an AMD Sempron that Ash sent me, simply because I don't think I have anything like this. I don't really know what type of Sempron this is. I could read the number. I'm hoping the motherboard starts and it's telling me. Let's be optimistic. And as a heatsink, just to be on the safe side, I found this, and I knew it was for an AMD thing, and I think it fits on this socket. I never used it, so it looks like it's exactly what I'm looking for. I'll use a little bit of thermal paste. I don't want to use too much in case, you know, I have to remove this. Just a little bit to prevent overheating, and then we'll see what happens. I don't even know how this works. There's a lever here, lever. Okay. And I'm good to go. Will it work? Well, let's find out. Power to the power supply now. And power up the board in 3, 2, 1, go. Oh, and the power supply shut down immediately, indicating that we have a short. So we have a short, but without the CPU. So I'm assuming that either the CPU is shorted, or the CPU is starting the VRM for the V-core and it's shorted. Let's try this again, but I feel like kind of uncomfortable. 3, 2, 1, go. It has started now, but it's not doing anything anyways. I haven't got anything, but there's no smoke. Why did this shut down immediately earlier on? Okay, so the first time I start in the board, it stops straight away. Then if I try again, the power supply still works. I'm assuming the whatever is shorted realizes it's shorted and it doesn't try again. That's very interesting. Well, this is V-core and it's reading 35 ohms, so that's really not shorted. It might be something else. Honestly, I don't know whether this CPU is working. I'm not entirely sure I have another one. Let's see whether what we are reading on the VRM when it's starting up, if it tries to start up. Now, the oscilloscope is in roll mode, and this is the VRM when I start the board the first time. 3, 2, 1, go. You see it goes up a bit, and then it stops. But if I try and power this up again now... Oh, it's happening again. No, earlier on it was actually staying. Let's give it a few more seconds. There we go. It stays and it's reading 1.47 volts, which I think it's fine for the CPU. So that's kind of suggesting the CPU is fine. Well, the VRM is fine. Otherwise, I wouldn't read that. Something else is not working here. I have a beeper here, so the board is not really doing anything. There's no code being executed at all. I have the lines on the postcard analyzer, so it's not even like it's a RAM problem. This is like I'm not doing anything, and this is going to be interesting to diagnose, I guess. I'm not sure whether you can see it. I got my current clamp meter connected to the 12 volts going for the VRM basically, and it's drawing 0.4 amps. So there's no short in there, what I can see, because otherwise this would read silly numbers. I had a motherboard once that was reading like 12 amps all the time. The power supply was hissing because it was being overpowered. But no, unless the something is sensing the problem and is stopping, I can go and check that we have a voltage out of all the 3 different phases. Alright, I managed to visualize the pulses from the 3 phases. This is phase number 1, the one on the right. This is phase number 2, which should be the one that we fixed. And this is phase number 1, the one on the left-hand side. So they seem to be working, unless they're overlapping each other, but at that point you would see like a massive short on the line and the power supply would draw quite a lot of power. So that seems to be working, which is good news, and this might be something else. And honestly, I don't know whether this board is supposed to work besides the phase issue, so I don't know. Let me think about it. Now I've just checked that none of these chips is scorching hot, and none is scorching hot but one, the North Bridge. The board is not doing anything, but the heatsink, which doesn't have a working fan at the moment, is very, very hot. I would say it's around 60 degrees, probably, yes, around 60 degrees. But the board is not doing anything, so yeah, it's uncomfortable to touch. It's a bit suspicious, and yeah, that would be a shame, because it's BGA, of course, is not something that you can fix easily. The rest of the board is completely dead, there's no postcode at all, but I feel that the VRM is fixed. Everything looks okay, everything checks out, the voltage is fine, so it must be something else. The next step would be the simple one, reflash the BIOS, you never know. So this is a PLCC32, I'm gonna use this little tool that not many people like. I don't like it either, but it usually works. Okay, it didn't work this time. Yeah, it's not the best tool. Okay, I'm gonna use it in an unconventional way. And I have a little adapter here. Let's see what the programmer says. The chip is already selected PM49FL002T. Let's try and read it. There we go. I'm gonna save this, as on the Retro Web there's only one BIOS, so in case this actually works, I can upload it if it's different. Now I'm gonna open the BIOS that I've downloaded from the Retro Web. Well, it definitely looks different. Let's verify it. It probably will fail. Yeah, I mean it's completely different. So chances are it's just a different version. Hopefully, it's just the reason why the motherboard is not starting. Anyways, we save the backup. Let's program this and hope for the best. Chip is successfully programmed and verified. Let's test it and let's hope for the best. Okay. Power up. 3, 2, 1, go. No. At least it started. But no, there is no activity whatsoever. Oh my gosh, this is not going to be an easy fix, if ever. Right, plot twist. I was diagnosing off camera, otherwise it takes absolutely forever. And I realized that this weird, I'm going to power on, power off, depending on how I feel, was only happening when the CPU 12 volts was plugged in. But then I realized, well, that's also powering the CPU, but also the North Bridge, so it could be really anything. So I tried removing the CPU, I was trying to follow in the path. Do I still see that behavior with just the North Bridge installed? That might indicate some weird things with the North Bridge, and it wouldn't really happen. So it looked like it was something with the CPU. I inspected the CPU, made sure that all the pins were there, and they were all there. Just put it back, and it lived. I just reseated it. Let me see if it's doing it again. Obviously, it's without heatsink. You can't see the postcode, but 3, 2, 1, go. Yes, I have postcodes, and it works! It just needed the CPU to be reseated. Can you believe that? It's the last thing I thought. Right, let me put it back together, because this thing works. I didn't do anything. I only just poked around, checked for the clock and stuff. Let me put it back together. Chances are it's working. Right, this is actually going to work. Let's try it. 3, 2, 1, go. Yes, it's doing something. Do we have... Okay, well, this could be the video card. It could be the RAM. Could be lots of things. I have... Which one is it? C1? Let me get a PC... Well, an AGP or a PCI Express feed. Let me fiddle with the video cards. I don't think that that's the RAM issue. I've got an old GT630 PCI Express. Let's see if that works. 3, 2, 1, go. Okay, doing... No, still doesn't like it. What is it missing that it doesn't like? Does it want an AGP card? Is it a RAM issue? Maybe it doesn't like the RAM. Let me try. Do I need 2 RAM modules here? Let me try with the different modules first. Oh, this is DIMM 2. Wait a sec. I'm in channel A, but DIMM 2. So let's definitely go with channel A dim 1. That might help. I mean, definitely in the wrong slot. Let's try this again. Right, still doing something. The GPU is doing weird things. The fan is going up and down. Oh, and the board is resetting itself all the time. So it's definitely not our problem. Do I need 2 RAM modules? I haven't got 2 identical RAM modules, but they're all the same size. No. Well, with this video card, the board is resetting all the time. So let's try it. Let's try something else. Let's try a different video card. Okay. Hello, vintage video cards, the bottom of the whole pile. Hello, yes, there we go, AGP. No, what does he want? Right, so I checked the manual and this board is supposed to support DDR 333 and 400, and I found these DDR 400 MHz sticks. The manual says it should work with just 1 stick in slot 1. So let me try some contact cleaner. I don't understand. This is definitely a memory error, because if I power up without anything, it's doing exactly the same. It's doing some codes, and then it stops on C100 with long beeps. So it's definitely 100% a memory issue. I can't remember how many times I fixed these machines by reseating and reseating and reseating the RAM, even though it looks like it's not working, but eventually starts working. So I'm not giving up yet. Let's try this one more time, or probably a few more times, and let's see what happens. Wait a sec. Is it? Oh. It's working! It's posting! Look at that! Yes! Sempron 3000 plus, 412 megabytes of RAM, DDR400 single channel. Amazing! It's working! Oh gosh! You know, off camera I've been testing so many different modules here. I went around the house trying to look for different modules. And I did try this module before. It's just, yeah, it just needs contact cleaner. Now I haven't got, the fan is not working. It doesn't have a socket, a plug. So maybe I want to make a plug. I have the tool to make a plug. I think it needs one. So maybe we can test it a bit. It's working! Fantastic! I was hoping to fix it. Let me fix this connector, and then we'll run some software and we'll test it and we'll make sure it works. Moo! Oh no, it doesn't fit. Oh, seriously? Oh. Now that the fans are connected, let's turn it on and let's boot into MS-DOS. I appreciate this is not an MS-DOS machine, but there is something that we have to do when we fix a vintage motherboard, right? And yes, this motherboard can run Doom. So again, sorry for the PC speaker, but the AC97 chipset on the motherboard doesn't have MS-DOS drivers, of course, and I really don't want to spend too much time trying to install a modern sound card with MS-DOS drivers. So next step, before we have a look at that BIOS and see if by any chance the BIOS that was in the motherboard is one that is missing from the Retro Web, let me see if I can quickly run Windows and make sure everything works, maybe run something real quick, maybe run the sound out of it, and then we go back to that BIOS. And I ended up reinstalling Windows XP just for the system, and I was totally expecting not to be straightforward. Windows XP is not the end of the world, but I wanted to try a new game, Far Cry, which I never tried myself, and as I was totally expecting, it took me absolutely forever. Missing files, issues with video resolutions, my capture device having issues, the sound capture device having issues, took me absolutely forever. Anyways, it's working, let's run it, and let's make sure that everything works fine.
You search the huts for weapons and equipment. Stay low and avoid contact if possible. You don't really want to alert the guards.
See something? You see that? Get him! Oh, I see you! Eat this! Bite my ass!
Well, that's a nice looking game. I've never played that before, but most importantly, the motherboard works totally fine. I guess if it works and Windows installs and the game plays, the motherboard is working 100%. Now, enough of me playing, I'd like to go back to the BIOS and check the BIOS version that we have right now, and then I'll program the earlier version and see whether it's something that we can save on the Retro Web. So let's go back on MS-DOS. Well, we don't even need MS-DOS, we're back to the BIOS splash screen, and I don't see a BIOS version unless it's the one within parentheses that says NF4 SAC21BF. But anyways, there's a date, 21st of December 2005, that matches the date on the Retro Web, so that's the one which is on the Retro Web. Let me go back to the previous BIOS, we'll check the BIOS date, we'll see whether it's newer or older. In any case, if it's working, I can upload it on the Retro Web. And we have a date of 2nd of August 2005, so this BIOS is slightly older than the one which is on the Retro Web. It's still a different BIOS, which is good, so it's worth saving it and uploading it on the Retro Web, but I guess I'll go back to the BIOS that I found on the Retro Web. And I'm back to the latest BIOS, and yes, the number between parentheses is the BIOS version, because now I got NF4 SA C21, and previously I had NS4 SA 802. I don't understand how a normal user can possibly understand which is which, but anyways, I'll make sure that the other BIOS is uploaded on the Retro Web. You never know, you might have some features, you might like something that other BIOSes don't like, so it's always nice to have a database. And with Doom running, I guess we reached the end of this video. It's been a fun repair. It's kind of easy, but not easy, because obviously I had to remove all those capacitors and it wasn't a simple thing to do, but nothing else besides some quirkiness and contact cleaner and drivers and stuff, the usual stuff with boards of this age, I suppose. Thank you very much, Ash, for sending me this board. I hope you enjoyed the video, and I hope you all enjoyed this video. If you did, as usual, I'd appreciate a thumb up down below, and also consider subscribing to this channel and my second channel if you like this kind of things. Don't forget I'm on Facebook and on Patreon, the links are down below in the description. There is a free tier on Patreon, so no excuses, but if you don't want to join me on Patreon, which is understandable, well, maybe you can buy me a coffee, and the link is also down below in the description. If you don't want to buy me a coffee, which is also very much understandable, well, I hope you enjoyed the video. That's it for today, thank you for watching, I hope to see you again soon here on my channels for my next videos. Thank you very much, and goodbye, bye bye.